Good morning, everyone. So let's start with OSPF filtering. So why we do filtering first? So it is process in order to avoid unwanted routes to be inserted in your routing table, or we call it as LSDB, link state database. So with OSPF, we can filter the routes on the ABR and the ASBR. And you can apply this filter in the inbound or the outbound direction. So you can filter the routes in OSPF only on the ABR and the ASBR. So now, I hope this is clear. Please make a note. Done. Done. Now we'll see how to filter the routes on the ABR. So we call it as type 3 LSA filter. So we'll be using following topology. So we have R1, R2, R3, and the R4. So these two are in area 2. These two are in area 3. And these two are in area 4. So every router has a loopback /32 and on the R2 as well. And we have one loopback, that is 1.1.1.1/32. So this will be under area 0. Then we'll see how to filter the routes accordingly. So we'll be designing this topology. So we'll be having 4 routers. So we have R1, R2, R3, R4. So R1, R4 will be in area 1. So R4, R2 will be in area 2. So R4, R3 and R4 will be in area 3. So we have a loopbacks in each and every router. So on R1, we have 1.1.1.1/32. This will be in area 0. Sorry, 4.4.4.4. We have 1.1.1.1 on R1, and we have 2.2.2.2 on R2. And we have 3.3.3.3. So the IP address between R1 and R4 will be 192.168.14.0/24. So between R3 and R4 will be 192.168.34.0. And between R2 and R4 it will be 192.168.24.0. So we'll use a notepad to configure OSPF. Then we'll see how to filter on the ABR. So who is the ABR here? Interface 0/0. IP address will be 192.168.14.1/. So here loop back. So IP address will be 1.1.1.1/32. So router OSPF 1. Router ID 1.1.1.1. Enable OSPF on all the directly connected networks. 14.0 wildcard mask, and area 1. Network 1.1.1.1, wildcard mask and area 1. This is the configuration on R1. So on R2, so interface Z0 bar 0. So IP address will be 24.2 and loopback will be 2.2.2.2. Router OSPF 1. So router ID will be 2.2.2.2 and enable OSPF 1 all the directly connected networks. 24.0 and 2.2.2.2 and area 2. This is the configuration on R2. So on R3, so interface Z0 bar 0, IP address will be 192.168.34.3. We have a loopback that is 3.3.3.3. Enable OSPF on all directly connected networks. Is the router ID? Enable OSPF on 34.0, area 3, 3.3.3.3, area 3. Finally, enable OSPF on R4. R4. So interface G0 bar 0, IP address will be 14.4. Interface G0 bar 1, IP address will be 192.168.24.4/20. Notion. Interface G0 bar 2, IP address will be 192.168.34.4/. Interface loopback 0, 4.4.4.4. So router OSPF 1, router ID will be 4.4.4.4. So enable OSPF 1 all the directly connected networks. Network 192.168.14.0, wildcard mask and area 1. So 34.0, area 3 and network 192.168.24.0, area 2. Enable OSPF 1 the loopback as well. Area 0. This is the configuration. Let's copy paste on R1, R2, R3, and R4. So who is the ABR here? Yes, guys. Who will become the ABR?
R4.
R4. Good. So R4 is our ABR. Now we'll see how to filter the routes on the ABR. First, we'll see inbound filtering, how to filter the routes inbound. Then we'll see how to filter the routes in the outbound direction. So before that, show IP OSPF. Two-way, ERBDR election. First, we'll check the routes. So R2, show IP route, OSPF. So I have 1.1.1.1, 3.0.3.3, and 4.4.4.4. In the same way, go and check R3 and R4. Show IP route, OSPF. So all inter-area routes. So we have 1.1.1.1, 2.2.2.2, and 4.4.4. Go to R1. Show IP route. 1 minute. Okay. Show IP route. So we have all the 3 routes. It is 2.2.2.2, 3.3.3.3, and 4.4.4. So let's say we want to filter 1.1.1.1 prefix entering into area 2. So now how to filter that? So we need to go to the ABR, go to R4. Now, so you need to create a prefix list. So IP prefix list. Here, whenever you are filtering on the ABR, let's say type 3 filtering. So your area ID filter list command only works with the prefix list. You can't configure access list, or you can't neither use the route map option. I'll show you in the configuration. We can't use either the access list or the route map. You need to configure prefix list only. So IP prefix list, provide the name, and I want to deny. What I want to deny? I want to deny 1.1.1/32. Then allow the rest of the traffic. Permit /0 LE32. Enter. Now go to router OSPF 1. Now, so I want to filter 1.1.1.1 entering into area 2. So the command will be area 2 ? Can you see here? We have a filter list. So you can apply a filter list in order to filter the routes ? Can you see? We can use only prefix list here. You can't use either access list or route map with this filter list. Prefix and the name. Cisco ? It will ask you inbound or outbound direction. So I want to filter 1.1.1 going into area 2. So I will apply it inbound. Enter. So now, as soon as you apply this filter, now R2 should not be able to see the route 1.1.1.1. Show IP route OSP. Can you see? I'm not able to see 1.1.1.1. I hope this part is clear. How to filter in the inbound direction. So I went to R4, configured a prefix list. You can use only prefix list. Show run pipe section. So I configured a prefix list denying 1.1.1.1, and then I allowed the rest of all the prefixes. Then I went to OSPF and applied the filter list. So area ID, filter list, prefix, Cisco in. So we go and check on R3 and R4. We'll be able to see all the routes. Can you see? I'm able to see 1.1.1.1. So we go and check on R2. R2 will not be able to see. I hope this part is clear. Anybody has any doubts with the inbound filtering? Yes, guys. Clear?
So this IP prefix command used in only this route filtering case?
You can use anywhere. Prefix list is just used to filter the prefixes. Not only in the, what you say. If you want to match any prefix and filter, you can use prefix list. Okay. But here in this case, I'm telling type 3, your area ID filter list, no, only what is only allows you to configure prefix list. It doesn't support either the access list or the route map. With filter list, you need to use prefix list only. Clear?
Okay, sir.
So any other doubts? No doubts? Okay. So this is about inbound filtering. Now, so let me remove this. Then we'll see how to apply outbound. No IP. Cool. So for this filter list. So now I will be able to see all the prefixes on R2, R3, and R4. I have all the three prefixes on R2, R3, and on R1. Now, so how to use outbound filter? Now let us consider I want to filter 2.2.2.2 entering into both area 1 and area 2. Sorry, not area 2, area 3. So if I want to filter the prefix 2.2.2.2 entering into area 1 and area 3. So now I need to configure what you say the filter list in the outbound direction. I need to go to area 2 and on the R4 you need to apply it outbound. Suppose if I want to filter this prefix going into area 1 and area 3. So you need to go to R4, configure a prefix list and apply it outbound direction. So IP prefix list, Cisco deny. What I want to deny? I want to deny 2.2.2.2/32. Want to allow the rest of the prefixes? IP prefix list, Cisco permit /0 only 32. Go to router OSPF 1. So area ID. So I want to deny this route. Filter list, prefix, name, and the direction outbound. Now, this time I don't want to allow this prefix to either to go to area 1 or either to go to area 3. Now, as soon as you apply, if you go and check on R1 and R3, you will not be able to see the prefix 2.2.2.2. You see, I don't have 2.2.2.2 on R1 and on the R3 as well. You see, I'm not a person. I hope this part is clear. Anybody has any doubts? The inbound and outbound filtering? You can ask me. This is about type 3 LSA filtering. Any doubts, guys? Anybody has any doubts? Clear? Everybody is clear with this inbound and outbound filtering? Clear. What about others, guys? Everybody is clear? Balaji, Darshan, Govind, Ranjita, Suhas. Clear? Okay. Then we'll move on to type 5 filter. Now we'll see LSA type 5 filtering. So in order to perform LSA type 5 filtering, you need to have a ASPR. Have an ASPR. Then you can attach a distribute list in order to filter the prefixes. So the topology we'll be designing is, so we have R1, we have R2, and we have R3. So R1, R2 is in area 0 and R2, R3 is in area 1. So let us consider we have 4 loopbacks. 172.16.0.0/24. We have 172 172.16.1.0/24. We have 172.16.2.0/24, and we have 172.16.3.0/24. So we'll be using redistribute connected subnets on the R1 in order to make R1 as the ASBR, and then we'll see how to filter the routes on the R1. So let's move on to the lab. We have 3 routers. So between R1 and R2, the IP address will be 192.168.12.0/24. Between R2 and R3, it will be 192.168.23.0. So R1, R2 is in area 0. So R2, R3 is in area 1. So we have 4 loopbacks on R1. That is 172.16.0.0/24. 172.16.1.0/24. 172.16.2.0/24. 172.16.3.0/24. Just use redistribute connected on R1 in order to make R1 as the ASPI. Then we'll see how to filter the routes. So let the console open. We manipulate our notepad. So on R1, so Z0 bar 0 will be 12.1. We have 4 loopbacks. That is 172.16.0.1/24. Loopback 1, 172.16.1.1/24. Loopback 2, 172.16.2.1. Loopback 3, 172.16.3. So router OSPF 1, router ID will be 1.1.1.1. So enable directly connected networks. That is 12.0 area 0, and use redistribute connected. Connected. So on R2, so Z0 bar 0 will be 192.168.12.2. We don't have a loop back here, and we have interface Z0 bar 1. address 192.168.23.2/. Motion. Router OSPF 1, router ID will be 2.2.2.2. So enable OSPF 1, 12.0, area 0, and network 192.168.23.0, 255, and area. We don't have a loop back here. So this is the configuration on R2. So on R3, so Z0 bar 0 will be 23.3. There is no loop back. So enable OSPF 1, 23.0, and area 1. Let's copy paste. So on R2, on R3. Wait for the adjacency. Extract. What happens in extract state? Yes. Are you guys there? Show IP, OSP. You have full adjacency. So master and slave election happens in the good Manoj. Master and slave. Show IP, OSP. I have one neighborship with 1.1.1.1. Troubleshooting. What is the call? Please check. Show IP OSP interface B. I am unable to form the adjacency with R3. Yes. Show IP OSP interface B. Yes, guys. Check the configuration of R2 and R3.
IP conflict, sir.
IP conflict where? Where? Which router?
No, actually R2G 0 bar 1 as 23.3.
Okay.
Even the R3.
Very good. Fine. Think. So it is 23.2. So go to interface Z0 bar 1. IP address 192.168.3.2/. Adjacency is done. There are two adjacencies. Show IP OSPF neighbor. And you will see OE2 routes. Show IP route OSPF. You will see 4 OE2 routes. Even on the R3 as well. Show IP route. OE2 routes and one OI inter area. Now, so you need to go to R1 and we'll see how to filter. Now, so let's consider we want to filter the first and the last prefix. So we want to allow these two prefixes and we want to filter the first and the last prefix. So how to do that? So you need to go to R1, create an access list, standard. So IP access list, you can use a name or a normal access list, numbered access list. So Cisco, enter. So standard Cisco. I want to deny first and the last prefix. That is 172.0.0.0.0.0.255. I want to deny 172.16.3.0.0.0.255 and permit any. I want to permit the rest. I want to deny the first and the last prefixes. Now, so you need to go to router OSPF 1. You need to attach the distribute list and the name. Word of your access list, that is Cisco. The direction will be out direction. So now, if you check R2 and R3, so we will not be able to see first and the last prefix. Can you see? I'm able to see 1.0 and 2.0. I'm unable to see 0.0 and 3.0. And even the same on the R3 as well. Can you see 1.0 and 2.0? What I did, I went to the ASBR. I created a access list, show run pipe section access. So I created a standard access list. You can use even the named access list, numbered access list as well. Then deny the prefixes 172.16.0.0 and the wildcard mask, and deny 3.0 and the wildcard mask. And this is mandatory command because by default, implicit deny statement is there. So if you don't use permit any, then all the prefixes will be denied by default. So then I went to OSPF process and applied the distribute list. I hope this part is clear. Anybody has any doubts?
No, sir.
Clear, right? Now, so this is one way. So there is another way in order to filter this. I'll show you that way as well. Let me quickly remove this. So no IP. We're able to see all the prefixes on R2 and R3. We're able to see all the prefixes. Now, so second method is with the redistribute command. So when you use redistribute connected command, with this command, you can attach a route map. Attach a route map in order to filter the prefix. Can attach route map and the name of the route map. So now how to do this? Now first you need to create a route map. So in order to create a route map, so here your access list will act as just as a selector. Now let us consider I want to deny the second prefix only. I want to deny this. I want to allow all the three. Now how to do that? So IP access list, standard Cisco, enter. This time you need to select this because the route map will take the action. So 172.16.1.0, I want to deny this 0.0.0.250. Enter. Now create a route map. Route map, Cisco, permit. Okay. This is a sequence number. You can use anything here. This is a sequence number. You can insert any sequence number here. Permit 10. Enter. Now match IP address according to the access list name. That is Cisco. This is my access list name. Enter. Now by default, a deny statement will be there. Sorry, my mistake. It was deny, not permit. If you permit, this will be deny. Deny. as the access list. So match IP address Cisco, then rest of the prefixes you allow using permit 20. So now you need to go to router OSPF. Just remove no redistribute connected. With that only you can attach this route map. So now how to do that? So redistribute connected, subnets. Question mark. Can you see? We can attach route map. You can't use a prefix list or a access list here. You need to use a route map in order to filter the prefix. Route map and the route map name here. That is Cisco. Enter. Now, if you go and check on R2 and R3, so you will not be able to see 1.0 prefix. Can you see? You are able to see 0, 2, and 3. You are unable to see 1.0. And the same on the R3 as well. This is the second way how you can filter the prefix. Here, what I did, I went to R1. So I created an access list just to select show run type section access list. So I created an access list here, standard access list, and I used permit. Here, access list will just act as a selector and route map will take the actions. Show run pipe section route map. So I created a route map. Cisco, I told to deny what you want, what you need to deny. You need to deny. So whatever is present in your access list. Cisco. So now we'll check the access list Cisco. What I told, I told to deny 1.0. Then another statement by default, implicit deny will be there. You need to permit the rest of the prefixes. And then you need to go to OSPF process and apply this using the command redistribute connected. And with this redistribute connected command, only you can attach the route map. You can't use either the access list nor the prefix list. I hope this part is clear. So anybody has any doubts? This is about filtering. Yes, guys, anybody has any doubts? Is it clear? The concept is clear, how to filter LSA type file. Clear? Okay, all right. So now we'll see OSPF authentication. Clear? Okay. So if we talk about authentication in OSPF, it supports 4 types of authentication. Any idea what are the authentication types? Yes, guys, any idea? We have type 1. We call it as null authentication. Sorry, this is type 0. So we have type 1. We have plain text. We have type 2, MD5 authentication. Now authentication must match in order to form the full adjacency. It also supports HMAC SHA. Authentication. These are the 4 types of authentication that OSPF supports. Please make a note of this. So by default, your null authentication is present. So now we'll see how to enable plain text, MD5, and HMAC SHA.
So this OSPF authentication we just need for securing our adjacency.
Securing your adjacency.
Yes.
This is to
Wha-
secure your rogue routers.
Okay.
So anybody connects with that, if they form the, they will not be able to form the OSPF adjacency until and unless the authentication is matched.
And by default, this is enabled or disabled?
By default, it is enabled. It is null authentication, means we don't have any authentication. It's not enabled. You need to go and enable plain text if you want, or if you want MD5, you can. So now the recent one is HMAC-SH. This is the most strongest authentication we have in OSPF.
Okay.
Clear? Clear, guys? Now, so we'll see how to enable plain text, MD5 and HMAC-SH. So just take two routers. We'll see how to enable plain text authentication. So area 0. So the IP address will be 192.168.12.0 slash 20. So let's enable OSPF first. Now authentication must match for the neighbor adjacency. First, we'll see how to enable the plain text authentication. So wait for the console. However, conflict. Okay. Interface is 0 bar 0. IP address will be 192.168.12.2 slash 20. Version. Enable the OSP. So router. OSP. Router ID 2.2.2.2. Network 192.168.12.0. Wildcard mask and area 0. Go to R1 and enable OSP. Host name R1. Interface 0 bar 0. So IP address will be 192.168.12.1 slash. Enable OSP. Router. Router ID 1.1.1.1. So network 192.168.12.0. Area. So let me enable the debug. debug IP OSPF adjacency. So packets on both the routers. So adjacency is done. You see, by default authentication type 0 is present, means we have null authentication. Clear? So now we'll see how to enable plain text. Let's check the adjacency. Adjacency is fine. Full. So now how to enable plain text authentication? You need to go to interface, enter. So IP OSPF authentication. First, you need to tell the mode. So if you want to enable message digest, you can enable message for plain text. There is no plain text command. If you enter, it will enable for plain text. IPOSPF authentication. Then you need to create a key here. IPOSPF authentication key and the password. So you can use any password here, and this must match on both the routers. Enter. Now go and check. They'll break down the adjacency because of authentication mismatch. Can you see here what it is saying? Bad authentication because you have enabled type 1 on R1. So they will break the adjacency. Show IP, OSPF, name. Can you see? There is no adjacency here. I need to go to R2 and enable the plain text authentication. That is type 1. So do undebug. So by default, authentication 0 is present. So it has break the adjacency due to authentication type 1. That is your plain text. So just go under interface name. The configuration will be IPOSPF authentication. Enter and IPOSPF authentication key. And this must match on both the routers. Enter. Now they'll form the adjacency. Can you see? They are on the adjacency. Clear? This is how you enable plain text. How to enable? Showroom interface. These are the two commands you need to configure. First is IPOSPF authentication and the key part here. I hope this part is clear. Any doubts with the plain text authentication? Clear, sir. It's clear? Okay. So now we'll see how to enable MD5. Sure. How to enable MD5? Just wait. Show IPOSPF. Membership I have now. So I need to go to interface name. IP OSPF authentication. Question mark. You can enable message digest here. We have null, message digest and plain text. Enter. Now you need to configure a key. Authentication. Question mark. Can you see here? You need to configure a key, and this password must match. Cisco. Enter. So break the adjacency. Wait for 40 seconds. Dead timer. Can you see? Dead timer expired. So adjacency is down. Show IP OSPF. Authentication must match. So go to R2 and enable MD5 authentication. So how to enable that? Go to interface name, IP OSPF authentication and message digest, and configure a key here. IP OSPF authentication Cisco. Show IP, OSPF. We have full adjacency. I hope this part is clear. How to identify? This is per interface. Now let us consider we have more interfaces here. So this is Z0 bar 1. So R1 is connected to one more router. So Z0 bar 1, Z0 bar 2. And we have one more interface, Z0 bar 3. So in this case, you can enable area-wide authentication as well. So OSPF supports interface authentication and area-wide as well. So now we'll see how to enable area-wide. So what we can do is you can go to router OSPF 1 and you can enable area-wide authentication. So how to do that? We'll go to router 1. OSPF 150. Sure. Interface 0%. So in order to enable area-wide authentication, you can go inside the OSPF process. OSPF 1. So you need to configure here which type of authentication method you are using. Either you are using plain text or MD5. But the key part, you need to again go to the particular interface and you can enable the key here. Go to the interface, IP OSPF, authentication, key, and key, that is Cisco. So you have if you have multiple interfaces connected to router 1, no valid authentication key. No, it is not. IP OSPF. Just wait. Hello packet. Oh, this part is clear, guys. So what I did. So if you want to enable area-wide authentication, you can go under the OSPF process and you can enable area authentication and the authentication mode. But the authentication key you need to configure under the interface only. I hope this part is clear. So anybody has any doubts?
For area-wide, do we need to configure it under the interface as well?
Yes, a key you need to configure under the interface, because if you go to the router OSPF 1, we don't have an option to configure the key here. So if you see here, area ID, question mark, you can use authentication. I don't know why it is coming. It is a bug, guys. Don't worry. Can you see? I don't have the key configuration here. You need to configure the key under the interface only. I can't configure key. Can you see here? It is not supported.
So we have to go to each and every interface and configure key.
Yes. Where you need to enable OSPF. You need to. Only the authentication type you can enable on the OSPF process. But if you want to configure the key, you need to go under each and every interface. Then you need to configure the key. Clear? Because there is no option to configure the key here under the process. Only you can configure the authentication mode. If you enter, it will become plain text. If you enter message digest, it will be MD5. I hope this part is clear.
Authentication key as per interface basis could be different as well, or it should be same everywhere in every interface.
No, I didn't get you. It can be different. So this is how you enable. So let us consider I have one more router connected. See, between the routers it must match. So let us consider I have one more router.
Okay.
So this is Z0 bar 1. This is Z0 bar 0. This is Z0 bar 1. Now between R1 and R3, you can use Cisco 123 or any other password you like. But this must match on both the interfaces. Clear?
Yes, sir.
All right. So now, so let's take a short break. We'll come back and we'll see SSH MAC and we'll start with BGP. Just an introduction to BGP. So tomorrow we'll see with neighbor states and message types. Okay, let's take a short break, guys. We'll meet back at 9:20. Okay, guys. Now we'll see how to enable HMAC SHA. Just quickly remove this. This HMAC SHA authentication you can enable only under the interface, not under the process. No. Now, how to enable HMAC SHA? So in order to enable HMAC SHA, you need to configure a key chain here. Key chain. And the name, this need not match between both the routers. Now you need to configure a key ID here. And this must match. Let us consider we use the key ID as 1 and key string. And this also must match. This is your password. We'll use Cisco 123. Enter. Then here you need to enable cryptographic algorithm. So you can use any algorithm here. So we'll just use the strongest one. That is HMAC SHA 512. And this must match on both the routers. So now you need to go under the interface name, and you need to just attach the keychain. IP OSPF authentication. Question. Can you see here keychain option and the name of the keychain, that is Cisco. Break down the adjacency. Just wait for the dead timer. IP OSPF. 7 more seconds. 6, 5, 4, 3, 2, and 1. Adjacency is down. Can you see it? There is no adjacency. Why? Because of authentication mismatch. Now you need to go to R2 and enable HMAC SHA authentication. So first create a keychain name. Then key ID, this must match, and key string. So, and cryptographic algorithm must match on both the routers. So we used HMAC SHA 512. Go under the interface and attach this keychain. 0/0 IP OSPF authentication keychain and the keychain name, that is Cisco. Now they will re-establish the adjacency. Can you see? We have a beautiful adjacency. I hope this part is clear. Anybody has any doubts? So what I configured? To configure a keychain section. So configure the keychain and the name. Configure the key and the key ID, and this must match, and key string must match. And then you need to say cryptographic algorithm. I want to use HMAC SHA 512, and this also must match on both the routers. Then you need to go under the interface and attach this keychain using the command IP OSPF authentication keychain and the name. I hope this is clear. Anybody has any doubts in the authentication part? Yes, Anand, guys. No doubts? Is it clear? Clear. Clear. Okay. So now we'll move on to BGP. Just a basic introduction today. So tomorrow we'll start with adjacency states and the message types. So BGP.
Sir, I think in OSPF we have not covered even OE1 routes and ON1.
That all will be covered in this one, a CCI enterprise. Okay.
Okay.
So BGP stands for Border Gateway Protocol. So BGP is an EGP protocol. Why we call it as a EGP? Any idea? Yes. So what about EGP? What's the aspect?
Work on different autonomous systems.
So BGP is mainly preferred between two different autonomous systems. So the only protocol which is used in the internet is BGP. So now the next question is, why BGP? Why not EHRP? Why not OSPF?
Scalability, it support a lot of routing database.
Routing database.
Routing information.
Routing
scalability point of view, it's better than all other.
Scalability, very good point. It is. First point is scalability. So what do you mean by scalability? So if we talk about EIGRP or OSPF or your RIP version 2. So what do you mean by scalability is, so in the today's BGP routing table, we have more than 8+ lakh routes, that too after aggregation. This is after aggregation, means after summarization. So BGP rich in attribute, good source. So first point is scalability, means BGP has the capability to handle more routes compared to your EIGRP and OSPF as well as RIP. The second point is BGP is rich in attributes. What do you mean by this? So if we talk about EIGRP uses bandwidth and delay. OSPF uses cost, that is your interface bandwidth to calculate the cost, and RIP uses hop count. Yes. So if we talk about BGP uses multiple attributes. So we have 12 attributes before BGP will select the best path. Just I'll give you an overview. It will check these attributes. First, it will check the next hop reachability. If next hop is reachable, then highest weight is preferred. Then we have highest local preference. We have locally injected. We have least AS path. We have origin. We have least MED. Then neighbor type. Then we have least IGP known metric. We have oldest eBGP route. Least neighbor router ID and least neighbor interface IP. So these are the attributes that BGP will check before selecting the best path. I hope it is 12 attributes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these are the attributes that BGP uses to select the best path. I hope this part is clear. Make a note. These are the attributes. and it will check in sequential order. First, it will check next stop, then wait, local preference, local injected, AS path, origin, MED, neighbor type, IGP known metric, EBGP route, oldest, and neighbor router ID, and least neighbor interface IP. Let me know once done.
So basically used at ISP sites, for service provider site.
Yes. Mainly preferred in the service provider. Inside the ISP.
So in our part means what kind of involvement we have? Let's say we are taking services from any service provider, and between us we are running IGP protocol.
You can run IGP protocol, but the redistribution from BGP routes into IGP will create an issue because your EIGRP and OSPF will not be able to handle more routes. So you need to be careful with that redistribution, because CE and P, you can use any protocol to redistribute. You can use either EIGRP or OSPF, or you can use even BGP as well.
Okay.
So when we redistribute any IGP protocol into BGP, you need to be careful because BGP has a lot of routes and it has the capability to handle that. That's why we almost prefer BGP only. Clear? Now, so if we talk about the points of BGP, first of all, we talked about BGP is an EGP protocol. Then the AD value. If we talk about the AD value, what do you mean by AD?
Administrative distance.
So what do you mean by that?
Trustworthiness of any routes.
Trustworthiness of an route. So if we talk about the AD, it is 20 and 200. So we have two AD values in BGP. 20 is for eBGP, that is external BGP, and 200 is for iBGP, that is internal. And eBGP stands for external BGP. So between two different autonomous system numbers, the AD value is 20. In between the same autonomous system number, we have 200. So that's why BGP always prefers external over internal. So if you talk about the algorithm it uses path vector algorithm. Means it keeps track of the paths inside the network. So what is the protocol number of BGP? Any idea? Protocol number is 179. Okay. What about others? Just agree to that. Is the protocol number 179 of BGP?
No, port number.
Yeah, that's a TCP port number.
Okay. What is the port number?
TCP 179.
TCP port number. Yes.
No, actually, BGP uses TCP 179 to communicate between the
179. So somebody asks you what is the BGP protocol number? Good manner. So how you need to answer? It uses protocol number 6 with port number 179. So because it uses the services of TCP. So that's why BGP is slow. So you need to have patience a little bit in order to get the routes or the exchange of routes inside the routing table. So because it uses TCP, TCP is slow. Because first it establishes a three-way handshake, then the data transfer. I hope this part is clear. Any doubts still here? No doubts? So it is protocol 6 and port number and with port number 170. Application layer. Okay. Now, so BGP has two flavors. One is IBGP. Internal BGP. So what I mean by internal BGP? Forming adjacency between same autonomous system numbers. So we have eBGP. It is external. Forming adjacency between two different autonomous system. So if you have R1, R2, ASN 12. So between R1 and R2, we are forming IBGP adjacency because both are in the same autonomous system number. If R1 and R2 are in different autonomous system number, let us consider R1's ASN value is 1 and R2's ASN value is 2. So 192.168.12.0/24. So the forming adjacency between R1 and R2 with different autonomous system number, we call it as EBGP. The VDA value of IBGP is 200 and AD value of EBGP is 20. I hope till here it is clear. So I'm done for the day. So anybody has any doubts, they can ask me. So tomorrow we'll discuss about adjacency states, message types, and we'll see the loop prevention mechanisms of IBGP and EBGP. First, we'll see how to form the neighborship, and then we'll see how to avoid the loops. I hope this part is clear. So anybody has any doubts still here, they can ask me. I'm done for the day. Everything is clear? Clear, guys?
Yes, sir.
All right, guys. So today we'll end up. We'll continue tomorrow. Have a great day, guys. Bye.
Thanks. Bye.